Gravitation. Introduction. The moon goes around the earth. In all these cases, there must be some force acting on the objects, the planets, and on the moon. Isaac Newton could grasp that the same force is responsible for all these. This force is called the gravitational force. We shall learn about gravitation and the universal law of gravitation. We shall discuss the motion of objects under the influence of gravitational force on the earth. Second law of motion. A force is needed to change the speed or the direction of motion of an object. We always observe that an object dropped from a height falls towards the earth. We know that all the planets go around the sun. Universal law of gravitation. Every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the centers of the two objects. Let two objects A and B of masses m and small m lie at a distance d from each other as shown. In figure, let the force of attraction between two objects be F. According to the universal law of gravitation, the force between two objects is directly proportional to the product of their masses. That is, F is equal to capital M into small m. The derivation for universal gravitational constant G is obtained as shown. Importance of universal law. The universal law of gravitation successfully explained several phenomena which were believed to be unconnected. 1. The force that binds us to the earth. 2. The motion of the moon around the earth. 3. The motion of planets around the sun. And 4. The tides due to the moon and the sun. Freefall. Take a stone, throw it upwards. It reaches a certain height and then it starts falling down. Whenever objects fall towards the earth under this force alone, we say that the objects are in free fall. Is there any change in the velocity of falling objects? While falling, there is no change in the direction of motion of the objects, but due to the Earth's attraction, there will be a change in the magnitude of the velocity. Any change in velocity involves acceleration. Whenever an object falls towards the Earth, an acceleration is involved. This acceleration is due to the Earth's gravitational force. Therefore, this acceleration is called the acceleration due to the gravitational force of the Earth or acceleration due to gravity. It is noted by g. The unit of g is the same as that of acceleration, that is, m s to the power of -2. Let the mass of the stone in activity be m. We already know that there is acceleration involved in falling objects due to the gravitational force and is denoted by g. Therefore, the magnitude of the gravitational force F will be equal to the product of mass and acceleration due to the gravitational force as shown above, where m is the mass of the Earth and d is the distance between objects and the Earth. Objects under gravitational force. Take a sheet of paper and a stone. Drop them simultaneously from the first floor of a building. Observe whether both of them reach the ground simultaneously. We see that paper reaches the ground a little later than the stone. If we do the experiment in a glass jar from which air has been sucked out, the paper and the stone would fall at the same rate. An object experiences acceleration during freefall. This acceleration experienced by an object is independent of its mass. This means that all objects, hollow or solid, big or small, should fall at the same rate. As g is constant near the Earth, all the equations for the uniformly accelerated motion of objects become valid with acceleration a replaced by g. The equations are shown above, where u and v are the initial and final velocities and s is the distance covered in time t. Mass. The mass of an object is the measure of its inertia. Greater the mass, the greater is the inertia. It remains the same whether the object is on the earth, the moon, or even in outer space. Thus, the mass of an object is constant and does not change from place to place. Weight. The weight of an object is the force with which it is attracted towards the earth. We know that F is equal to m into A. That is, F is equal to m into g. The force of attraction of the earth on an object is known as the weight of the object. It is denoted by W. Substituting the same in equation, we have W is equal to m into g. Weight of an object on the moon. The weight of an object on the moon is the force with which the moon attracts that object. The mass of the moon is less than that of the earth. Due to this, the moon exerts lesser force of attraction on objects. Let the mass of an object be m. Let its weight on the moon be Wm. Let the mass of the moon be m, small m, and its radius be Rm. By applying the universal law of gravitation, the weight of the object on the moon will be equation 1. Let the weight of the same object on the earth be We. The mass of the earth is m and its radius is r. Equation 2. Substituting the values from table in equations 1 and 2, we get equation 3 and 4 as shown above. Dividing equation 3 by equation 4, we get weight of the object on the moon by weight of the object on the earth is equal to 1 by 6. Weight of the object on the moon is equal to 1 by 6 the whole into its weight